Quite often we're having to solve index equations, and the way in which we do that is to make sure that both sides of the equation are written in terms of the same base. So if we had 5 to the power of x is equal to 5 to the power of 2, because the base numbers are the same, that means the powers must be the same. So then we could say that x is equal to 2. But if we had 10 to the power of x is equal to 5 to the power of 3, because 10 and 5 are not the same base, we can't simply say that x is equal to 3. We would have to try and manipulate the 10 into a power of 5, which in this case can't be done. But if we had 9 to the power of x is equal to 27, well, both 9 and 27 are powers of 3, so 9 is 3 squared and 27 is 3 cubed. We could use our rules for indices by expanding out the bracket, multiplying the indices together, and we'd get 3 to the 2x equals 3 cubed. And now the base numbers are the same, so if the base numbers are the same, then the powers must be the same. So we could say that 2x is equal to 3 and x is equal to 3 over 2, or 1.5. So the object here is to try and write it in the form of the same base number. So example A in the notes, we've got 3 to the power of x equals 27, so very similar to what we've just looked at. We need to try and express 27 in terms of 3. We've just said that 27 is 3 cubed. So now, because the base numbers are the same, the indices must be the same, so then we get that x must equal 3. Example B, we've got 7 to the power of 2x equals 1 over 49. So we need to try and get the 49 in terms of 7. Now we should know that 49 is 7 squared, so I'm going to write that as 1 over 7 squared. But again, I need to get it in the form of 7 to the power of. This isn't 7 to the power of, it's 1 over 7 squared. But our rules for negative indices, or whenever it goes to the reciprocal, so I could write this as 7 to the minus 2. So now what I've got is 7 to the 2x is equal to 7 to the minus 2. The bases are now the same, so then the powers must be equal. So 2x must equal minus 2, so x is equal to minus 1. Example C, 5 to the power of x plus 1 equals the cube root of 5. Cube root of 5, we need to write that in terms of the base 5, and that's going to be 5 to the power of a third. So whatever the root is goes onto the denominator, and the power of 5 is the numerator. And there isn't a power, which means the power is 1, so it's 5 to the power of 1/3. So now we've got a case where the bases are the same, so then the powers must be the same. So what we can say is that x plus 1 is equal to a third, and if x plus 1 is equal to a third, then x is equal to a third minus 1. So subtracting 1 from both sides, and we get x equals minus 2/3. Example D, what we have is 8 to the power of x equals 1 over 32. Now the powers of 8, you've got 8, 64, 512, so 32 doesn't appear in that list. So we need to try and think of a smaller number, a smaller base number, whose powers will go into 8 and 32, and that's going to be 2. So 8 is 2 cubed, so 2 squared is 4, 2 cubed is 8. And 32 is the 5th power of 2. So you've got 2, 4, 8, 16 and 32. So that's 2 to the power of 5. My rules for brackets are I multiply the indices, so I get 2 to the power of 3x. And for fractions, that's whenever I take it as a negative power, so that's 2 to the minus 5. Now I've got it in the form of the same base, so then the powers must be the same, so 3x must equal minus 5. Dividing 3 by 3, I get x equals minus 5 thirds, or minus 1 2/3. And the last example, we've got a ninth to the power of x equals 27 cubed. Now the powers of 9, we get 9, 81, 729, so 27 doesn't appear in that list. So we need to try and express 9 and 27 in terms of the same base. And we've got to go smaller, and that's going to be 3. So 3 squared is 9 and 3 cubed is 27. So we'll write it as 1 over 3 squared to the power of x equals 3 cubed to the power of 3. So we've expressed 27 as 3 cubed and 9 as 3 squared. Our rules for brackets are that we multiply the indices, so that's going to be 1 over 3 to the 2x. Again, whenever they're in brackets you multiply the indices, so it's 3 to the 9. We need to express this as 3 to the power of. Whenever it's in a fraction with a numerator of 1, that's going to be the negative rule, so that's 3 to the minus 2x equals 3 to the 9. Now we've got the form where the bases are the same, so then the powers must be the same. So minus 2x must equal 9. Dividing through by minus 2, we get x equals minus 9 over 2, so x equals minus 4.5. Just something to be careful of. If we have 5 to the power of a third, make sure that you put it as to the power of a third. It is not equal to 5 and 1/3. So whenever you're writing powers, make sure you write them small and as a superscript, as a power. Try to make that really obvious. The same with roots. If we want to do the cube root of 5, make sure that it's the cube root of 5 and not 3 times the square root of 5. So hopefully you can see the difference there. This is a smaller 3, that's on top of the root sign, this is in front of it. And this would mean 3 times the square root of 5, whereas this is the cube root of 5. We can see, if I bring my calculator in, the cube root of 5 is 1.71, whereas 3 square root 5 is 6.71. So they are different, and we just have to be really careful how we write those.